Hello everyone, my name is Shivani, and today with my teammate Manisha will be demonstrating to you our web programming final project, which is Conway's Game of Life. The agenda for today's presentation is as follows. Firstly, we'll go through what is Game of Life, we'll see some history, we'll see what are the game rules, we'll see the patterns used in the rules, and then we'll see how we actually implemented the game, we'll see what technologies we used, we'll also see code snippets, we'll go over the testing that we did, and we'll give you a demo. So, what is Game of Life? Game of Life is a no player cellular automation game. It's not a typical computer game. So, this game was widely known when it was mentioned in an article published by Scientific American in 1970. So, this game consists of collection of cells based on a few mathematical rules which can live, die, or multiply. Depending on the initial conditions, the cells form various patterns throughout the course of game. The first game was invented and thought over by John Newman, and he defined it as life and called it as creation, which can reproduce itself and simulate a turning machine. But he thought that it was not so realistic. Motivated by John Newman, John Conway began doing experiments in around 1968, and he formed various 2D cellular automation rules. So, hence, Game of Life was then formed. Why is Game of Life so important? So, first of all, Game of Life comes into important because it can help studying the patterns of life, which can result in discoveries in other areas of maths and science. Also, one can predict behavior of cells in animals. One of the major things that can happen because of Game of Life is to analyze the traffic problems by using these simulations. Also, fixing computer viruses, curing human diseases, and exploring galaxies. So, what are the rules of the Game of Life? So, the first bird's eye view of the rule is that the game is played on a grid of infinite squares. The cell can be considered as alive or dead. Every cell interacts with its 8 neighbors, which are cells that are horizontally, vertically, and diagonally adjacent. So, at each step in time, the following transition occur. That is, the cells can be live or the cells can be dead. Firstly, the rules for live cells are any cell with 2 or 3 live neighbors lives on to the next generation. And if any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. Fewer than 2 live neighbors, that is, that cell dies as if by underpopulation. If there are more than 3 live neighbors, the living cell dies as if by overpopulation. Let's see some examples of different stages of the cells, which are called generations, and the change in generation till it reaches nothing, repeat, or stable state is called evolution. So let's go over to the first example that you can see on the screen. So as you can see, this is the first initial state, and let's see for this cell. In the 8 directions that we see, only one cell is present, which means that this cell will die because of underpopulation. For the second cell, there are exactly 2 cells present, so this cell will live on. For the third cell here, only one cell is present, which means this cell will die. For the cell here, there are 3 cells present, so this cell will be reproduced and this will be the state. After this state, no change will happen. This is called one cycle of evolution. As you can see, the following are the different types of evolution. So these are another example of evolution. there are different patterns in game of life. The first pattern that you're going to see is still life. This pattern do not change from one generation to next. The second pattern is oscillators. The oscillators return to their initial state after a finite number of generations. The third pattern is spaceship. Spaceship translate themselves across the entire grid. So these are the few examples of still life: block, loaf, beehive, boat. As you can see from the example, block or loaf does not change its pattern. So these are oscillators. So as defined for the oscillators come to their initial state after few generations. These are four types of oscillators: blinker, beacon, toad, and pulsar. The next part of the slide will be showed to you by Manisha.
That we have used here are PHP, HTML, CSS, JavaScript, and for the database connectivity, we've used SQL. So these are some of the code snippets that are shown as a part of the presentation. So this is basically the registration form. We have used PHP. So the registration form takes the inputs of the name, the last name, the user ID, and the password. So, and we have put a specification that the password should at least contain 8 characters, 1 capital letter, 1 number, and a special character. So on successful creation of successful registration, the user can log in. So, and yeah, we've created tables. One is the logins table, and another is players table. And these are just some statements to see whether the tables are created successfully or if there is an error while creating the table. So the logins table basically stores all the names, the user IDs, and the passwords of all the people who've logged in. And when we create the table players, so all the players who register themselves, all the data goes into those tables, and this is also done in PHP. And so for buttons, we have tried embedding different kinds of styles, and there are many buttons, as in, like, for instance, for initiating the game, there is the play button, then there's the stop button, then 23 next is a button that we've given for 23 generations count, and then there's clear button to clear the board, and so on. So yeah, this is a code snippet that calculates the next direction, and it's pretty clear actually. So yeah, this is the CSS file which clearly shows all the styles that we've used, the background colors, the border radius, the kind of fonts that we've used, the size, so the padding, alignment, everything as such. So with respect to the testing, for instance, if for button validations, to see if the button is being displayed as we expected, connectivity to the database, so we've tried taking them individually and checking if they were giving us the desired output. So then we proceeded with some functional testing to see if the patterns, for instance, be it the oscillators pattern, to see if it is being generated and displayed as expected. So after every individual chunk was working as expected, we've integrated them all together to see there are no breakages, and then we've tested it on the whole from end to end. Now let us proceed with the demo. So basically this is how the user registration form looks like. The user is expected to give his first name, last name, user ID, and the password. Let us try giving the details. Say Manisha. We've mentioned a specific criteria for the password, that it has to be at least 8 characters with at least 1 special character, 1 capital letter, and 1 number. So I'm just giving a password that doesn't have any of it and trying to register and see if it works. So here it threw me an error stating it doesn't meet the criteria specified. So right now I will give it in a way that it meets all the criteria. So, and I'm trying to register now. Well, it got registered, and now I'm trying to logging in using the same credentials. So, yes. So yeah, after logging in, we can clearly see that the user ID that I have given as a part of registration is displayed here, and this is how the Conway's game of life looks like. So here we can see some patterns already being generated. So when I stop it, it becomes very static. So I can clear the board and try it with a new board. And the grid size that we have mentioned here is 60 by 30. So when I click on step, it increments by one step. And 23 steps is basically for incrementing it 23 steps. So yeah. We have also mentioned the generation count and the life cells, and we'll get a better picture of why we've used them right now. So let us consider one of the pattern that we've used here, which is still life. So in still life, the cells stay in the same place even in the next generation. For instance, okay, let me click on play. So if we see the generation count is incrementing here, but the number of life cells, the count remains the same. So let me take another step. So the count is being incremented here, but the number of cells remain the same. The next one is Gosper glider gun, in which there are two fixed blocks which are very static. So this gun shaped the cellular pattern works as a gun, and it releases the bullets, which are also called as gliders. Here we can clearly see the generation count and the life cells changes depending upon the patterns that are being generated by it. So the next one is oscillators. Here there are repeated patterns that would be generated infinitely, and depending upon the initial state of the pattern, it may take one generation or three generations or many other generations depending upon the initial pattern. For instance, let us consider the first one. It is just a very simple pattern. When I click on play, it just takes one generation to come back to its original pattern and is repeating in that loop infinitely. So, and we can see the corresponding count of it and the life cells. And to see the score of the scoreboard, we just click on the scoreboard and it displays a list of all the players that were there, their corresponding generations, the population, the date and time in which they played. So if I would like to go back to the game, I just click on this, and this summarizes the overall strategy that is behind the game, and I really hope you liked it. Thank you so much.